So good evening to all. Is the audio and video clear for everyone? Say. Thank you. So let us start our today's session. So the objective of today's session is, one, I want to take a problem on assignment model in which you have some blanks are given. That is one. Secondly, I go with the doubts what we have specified earlier, that there is one degeneracy problem in transportation problem which you have asked in the group that I want to take to solve the doubt clarification. Then again, can we do maximization in TP by multiplying all elements with -1? That is also correct. If you're interested, let us do a problem with this type of problem, right? So this is the objective of the session. If time permits, then I will go with one more problem on the assignment model. That is the objective of today's session. Is that fine? So do you have anything to add? If you have any other queries, you please respond. All right. So let me take the problem first. And I have given one picture in Telegram that how to draw the horizontal and vertical lines in an assignment model. So if you want a specific procedure, that procedure you need to follow. Clear? However, most of the times we draw the lines by the method of inspection. By simply observing the zeros and tabular values, we can draw the lines. That is practically possible. Okay. So let me take the problem first in the assignment model. So here is the problem. So please take a note of this. So the concept of this problem is, let us assume that we have a multinational company. There it want to set up an office in a building. Now what happens? The company has 5 managers, say M1, M2, M3, M4 and M5. And in the floor which is allocated there in the building, they have certain rooms available, especially in the 3rd floor. Room number 1 to room number 5 are allocated. 301, 302, 303, 304, 305. Now, there is an option given to the managers that what is our order of preference in selecting those rooms. So this is the order of preference for the first manager. Like that, everyone has given the order of preference. Here, some rooms are not mentioned, means they are not interested if they want to get a chance to settle there. They don't want to take those rooms. They have given the preference only among the 3 here. So our thing is, we have to assign rooms to the managers so that the least positive and good assignment is possible. That was the whole idea. Fine. Is the concept clear for everyone? Any more queries to anyone with regard to the concept of the problem? Right. Now what happens whenever there is no preference given, we left them as blank if you frame a tabular data for them. So you can take the order of preference 1, 2, 3 like that for their order of preference. So if you frame the tabular data to it, M1, M2, M3, M4 and M5, and considering the room numbers 301, 302, 303, 304, 305. Now I will write the respective numbers as so 42-1 and then 11512 and then 2 blank 14, again blank is there, and then I have 32333. I will write the value here, and for the last one the preference is given by. So please check whether I have filled the gaps in a correct manner or not. So here manager 1 has given preference number 1 to row number 302, so I have given 1 here. For 3 he has given preference 2, for 4 he has given preference 3, 301, 305 are not there for him. So that I put a blank there. Is it fine? The order of preference, what I have written there. Right. So for solving the problem, what happens? These things are not mentioned. So I will take a symbol M. M stands for a huge value, or the last preference you can call, or you can call it as a penalty, whatever you want. In some situations, if you talk of amounts or prices, you can take it as infinity. Huge amount you need to pay, like that. So usually you can take blanks or the symbol M or the symbol infinity. So whenever preferences are not clearly mentioned, is it fine in filling the tabular data? Now the rest of the thing is nothing but just doing the assignment model. So for each row we go with subtracting the smallest element in that row, likewise doing for all the rows. Then we go for each column subtracting the smallest element in that. Then we are going to do the necessary allocations there. Is that fine? The way we are going to proceed later. So in the first row, the smallest element is 1. You are going to subtract 1 from each and everything. So it becomes M, it will be 3, 1, M, and this will be 0. So can you do it on your own? So I will write the respective table if you have understood this in a clear manner. Can I? M is usually very huge, right? So there is no need of writing M-1 separately because M is a penalty. You treat it as infinite. That's it. So here it comes like this: 3, 1. The smallest is here. So 0, 0, 0, 1. Again here the smallest is 1. So 1, 0, 3. Here the smallest is 2. So 1, 0, 1, 1, 1. Here the smallest is 2. So it becomes 1, 2, 0. You please check on that. Is that clear with regard to your value? And there is no need to go for column reduction because each column contains a 0 as well. And at the same time, I can say it is 0 at the end. M3 to M3. Four value must be. So can you give the room number and the manager number? 302 to M3, right? It must be 4. Fine. Is it acceptable with the solution which you obtained? Any more modifications? Say, is it clear? Right. Now, you are going to allocate the values. So coming to the first row, we go for an allocation here. There is no more 0 in this column. Here you have 2 zeros, so we will left. Here you have only 1 0, so we should go with this. And again you have only 1 0 here. So since 1 0 here, you should cross this one. To cross this one, and it will be allocated. So is this alignment perfect? The allocation of values. Therefore, if you observe that since there are exactly 5 allocations, there is only way to draw exactly 5 lines so that you can cover all the zeros. That is the only way. As and when the number of allocations are less than the required, then you can draw that much number of lines. So since you have 5 allocations, this is the optimal assignment. So from this we can conclude that manager 1 takes 302, manager 1 5 takes 301, like that. This is the optimal assignment at the end. This is one model we will do in the assignment problem. Fine. Is the concept clear? Any more clarity you need over this? Then in the same type, I want to take one more thing, which is nothing but traveling salesman problem. There we go with similar kind of things. Fine. I want to take a problem on this. Can I? Okay. So this is the problem. I just want to write the matrix straight away. So please take a note of the values, then I will go with the discussion. What is the concept there? After noting, you please inform. Right. Now just imagine a situation that suppose we have a postman, and postman has some letters he want to deliver. Now, what is the arrangement usually a postman will do for serving those letters? He will arrange them in the order of distance 1, and what is the first destiny and what is the last destiny, so that no destiny will be repeated in the middle, isn't it? If you take the case of a postman who delivers the letters, or a courier boy, whatever it is the objective clear? In the same way, if I am a salesman, a traveling person, so here I have 5 cities or 5 places, let me say A, B, C, D, E. I want to travel from any one of the city so that I can visit all the cities exactly once and I will return back. That is my goal. Sometimes you can say that I can start at any one of the city and I should travel all the cities exactly one, such that no city will be repeated and I will stop at the last city. That's it. That is also a kind of problem. The numbers in the matrix simply resembles, sometimes they are nothing but the cost values or ticket values. Sometimes they will resemble the distances the person will go on to travel. So what are the thing in the matrix is, the objective is nothing but either minimizing the distances or minimizing the traveling cost. So if we assume that in the given problem, the values 4, 7, 3, 4 are simply nothing but the cost values or ticket values, you can call. Either they may be in rupees, hundreds or dollars, whatever it is. And the value M indicates that the route is prohibited. There is no need to travel that, or there is no need to visit that again. Clear? Or sometimes the distance is very huge. You can assume like that. Are you getting the thing? Yes or no? Right. So now, actually, if you think of this, the traveling salesman problem, it is just like an sequencing problem. What is to be done next? What is the order of preference? But actually, we solve this by means of the assignment model, right? So we can treat it as a special kind of assignment problem. We can treat like that. So the rest of the problem is very simple. We simply do the row reduction as well as column reduction. So you can simply perform the things, subtracting the smallest value from each row and as well as the smallest value from each column, and you are going to make the assignments. Is it that fine? So the procedure is simple. So the value of M, either it is given as blank or infinity, whatever is, we don't consider into the participation. We do the exact procedure for the rest of the values in the matrix. That's it. So you please do the things on your own, and I will wait the necessary matrix so that we can have a discussion on it. Okay. So can you perform on your own the reduction process? Right. So you please check on the value what I have obtained there. If there is any discrepancy, we're going to have. after doing the allocation. So you please check on that. CD value must be 2. Okay. Any more modifications we have? Did all of you have finished this? Okay, you give me the values then, A and B. So you have performed both the things, row reduction as well as column reduction. So M1301, fine. Then 1M201, so the allocations will be different. What about the remaining rows? Correct. Rest is okay, right? E003M, right? Correct. Okay, 2M. Accepted. I am taking the inputs from your side. Is it fine? Right. Now, is this assignment optimal? Because if you have taken the thing that A wishes to go to D, and for B there is no allocation, C wishes to go to E, and D for B, so D goes to B, and E goes to C, and C goes to E. Isn't it? So do you have a different value for row D also? I have taken the values from the previous things. So let us go for a total arrays. I will just take the values from your side so that don't get confusion. You just give me the row number value first, the first row values. So M1301. Then you have 1M201, right? Then 1M20, then so 0003M4, 003M4, right? 0003M. So by taking, you have one allocation here, it gets cancelled. Again, you have an allocation here, you have one allocation here. We have double things, you have double things. Coming to this, you have one allocation here, these two things gets cancelled. Is that right? Yeah. Right. Now what happens there? You cannot say that it is the optimal assignment. Now you are going to draw the lines. Now, what are the least number of lines that you wish to draw? 4. So, row number D, row number E, column D, column E. So, what about remaining zeros? We cannot do an assignment. So, if you have to do an assignment, means the row and column should have only exactly one thing, right? In the assignment, did you find anything like that? So, if you want to go for an assignment, you can choose among the two one arbitrarily. Let me say you have done this thing arbitrarily. You should cross the other. That's what I am asking. Whenever you have two zeros, you should go arbitrarily. You can allocate the things at anywhere. So you can pick up this thing or this thing, whatever it is. One thing should be arbitrarily taken. Because a zero is there, you need to allocate something there. That's the logic. Answer will be different. Because an assignment problem will have multiple solutions, right? So if you take the first column, since it has two zeros, you should go with the first one. The rest of the zero gets cancelled. That's the issue. Right. Now you know that the minimum number of lines required are nothing but 4 to cover all the zeros. So these two rows and these two columns, you wish to draw the lines. Accepted? Please understand that the solution is always optimal. As and when you reach the number of allocations, the solution which you have obtained there is nothing but optimal solution. Because here you are not finding anything separately, you are just finding the allocations here. So what happens, let me say, if you have the same distance traveled by selecting two different routes. So which route you are going to prefer is up to your choice with regard to the real life significance. What are you want to choose? But the minimum distance is same by doing such type of allocations. Okay? Right. So these two rows and these two columns, we wish to draw the lines. Am I correct? You require 4 lines to draw. Yes or no? Right? So if you draw the lines here, that is the resultant matrix. So to get the optimal assignment, you need to take the smallest element here and subtract from the uncovered values, and the same smallest value will be added as and when you have an intersection found there. Okay? Then again we do the reassignment and we do the same problem. That's the thing. Nothing else is there in assignment model. So the smallest element remained is nothing but 1. If you subtract here, it will become 0, 2, 0, 1, 1, 0. As and when you got an intersection, there you are going to modify it. So here you are going to modify it. It will become 5. It will become 4. Now you go for the reallocation again. And tell me whether you got exactly 5 allocations or not. Then the problem is done. You have made the assignment. That's it. So if you want a specific procedure of selecting or drawing the horizontal and vertical lines, which is given there, what happens? The step 1 is nothing but you go for the rows where there is no assignment. Then step 2 is you mark that row. If the row contains any 0, you mark that column. And the next one is take the rows which you have an assignment, mark them. Later what happens? You draw lines for unmarked rows and marked columns. That is the procedure given in a short note. So for majority of the cases, that thing works. So what is meant by further steps? If you have done the allocations, then it is completed, because you are just doing an allocation there. So here you are starting from which city, can you say? And are you returning to the same city or not? Are you returning to the same city or not? In this question, the route is always to be continuous. So just give me the allocations what you have made there, so that I will give the route. So give me the allocations, right? So if you have done this thing, let us erase the values. It contains 2 zeros, won't go for this. It contains 2 zeros, 2 zeros, 2 zeros. And if you go with the columns here, it contains 1 0. And we will cross this thing. And whenever you have 2 zeros there, you can choose one thing arbitrarily, because an assignment problem will have the multiple solutions. That we should need to know. So let us go with your assignment. So what is your assignment done there after doing this thing from your side? So we can check the multiple solutions what are obtained there. Right? B to A, fine. Then you have A to B. Again, A comes to B. Right? So you have an if and only if thing there. Then C to E. Then E to C, again you have the same thing again, right? Only 4 left, that is D to D itself. But D to D is prohibited, right? You cannot choose that. It is right. So anyone has any different allocation apart from this? Okay. So do you have the row values and column values exactly similar for you in this? So M0201, then 0M100, the last thing is 0 or 1? Right? Then you have 21M30, right? So let us go with the part. Suppose I have taken allocation for this one. The zeros here gets cancelled. If you have done an allocation here, these two things gets cancelled. These things gets cancelled. Nothing is left here. And this is completed. Coming to the columns. So here you get structured here, A to B. Yeah, I started with the arbitrary. In E column, there is only one. First E to C, right? Then if you take E to C and C to E, the same thing you are reversing back, right? You should go to another place. You should not come back. Because I just got stuck there. Because I have a different answer here. That's why I am following your way. Okay, just hold on a moment. Can I give the detailed solution separately on paper? Thank you. So excuse me here for this case. So let us go for the other one. Thank you. Because my answer is somewhat different. Right? So other thing is, you have asked about one degeneracy problem, right, in transportation one, which you have asked. So this is the problem actually given. Garages A, B, C, and you have 1, 2, 3, 4, 7, 6, 9, 12. This was the actual problem which is given there. I think everyone has seen this problem in the Telegram as per the postage is concerned. And coming to the solution part, actually there is a symbol M came here. There you got much confusion, right? Actually, it is a printing mistake in the problem. So there he has given M that this route should be prohibited. You should not enter into this route. It is prohibited there. That's why it is a penalty indicated with the symbol M. So you should take a note of that. But actually the solution contains the symbol M. The question itself didn't give the symbol M there. I have referred two more textbooks. They have the same printing errors, where you have extracted those problems. Not only one. So the same two textbooks have the same printing errors. That's the issue. Since it is an unbalanced problem, we have introduced a dummy column there by introducing 0, 0, 0. So that we can make it balanced. And what will be the value there? 10. So that the value becomes balanced. It is a balanced transportation problem. So can I say that everyone will have the solution of it or not? Please tell. If everyone has seen the material, it is okay. Otherwise, I will give the postage. Yes, it cancels twice at 0. At this position, it cancels twice, right? At a time. The row and column gets cancelled. Okay. So just hold on a second. I will give a postage to you. So that for how many of you the material is dispatched, may I know? Not yet. Yes, we can do it right now. We will do that also. For those who didn't get the material, I have given the postage, you can cross check that, and we will do the problem right now. Right? So let us calculate the penalties there for each row as well as column. So taking the smallest, difference between the smallest here, if you go for the penalties, here the penalty is 6, here the penalty is 7, here the penalty is 7, here the penalty is 1, here the penalty is 1, here the penalty is 1, here it is 2, here it is 0. Accepted with the penalties, say difference between the smallest and the next smallest. We are applying the VAN method to calculate it. Right. So you have the highest penalty occurred at the two things, 7 and 7. So which one you want to choose? Second row or third row? Third row. So if you go with the smallest one, here you got the thing 0. 10 and 10 both are same here. So we will get the cancellation of the things at a time. Row and column as well. So the allocation is nothing but 0 into 10 here. That is 1. Again we go for calculating the next penalties. Here the penalty is 1. Here the penalty is nothing but m minus 6. Here the penalty is 2. Here the penalty is 2. Here if you go with the penalties, the penalty is 1. Here the penalty is 1. Accepted? Right. Among which is the huge penalty? M minus 6. So in which we are going to the smallest one. So 6 is the thing there. I think everyone is following with us. Any queries for anyone so far? Am I moving fast? Are you getting me? Right. So if you check for the demand and supply, 3 is the smallest one, 6 into 3 you will get. Then this thing gets cancelled and it will become 9. Accepted. So again, we recalculate the penalties as well. So coming to the first row, the penalty is 2 here. Here the penalty is 1. Here the penalty is 1. So here the penalty is 2. Here the penalty is 2. Again, which one you want to go? The column or the row? After calculating the penalties, row. So the smallest element is nothing but 2. Check for demand and supply. For the smallest one, 7 fours we will get, and it will become 5. So this gets cancelled. Again, let us calculate the penalties there. The penalty is 2. It is 2 again. Here the penalty is 3. Here the penalty is 3. Now where you want to go? You have 2 rows. Which one you want to select? First or the second? First row, in which 9 is the smallest one. Let us go with this. So the value 9 into, if you check for the demand and supply, both gets cancelled at a time. Am I correct? Right. So what the thing remained there? These things gets cancelled. You have 10 is left here. The penalty is 10. And here 8 and 8, it is a balanced one. So 10 into 8 will come. Accepted. 10 into 8 is the final one. So what is the total value? If you sum up all the values, can you give summing up all these values? 171, right. Now if you check that 1, 2, 3, 4, 5, you got 5 allocations there. Now what happened here? If you check for that, you have 5 columns and 3 rows, total 8. So you should have 7 allocations. 7 is the required number of allocations, but you got only 5 allocations here. Am I correct? So we call it as a degeneracy at the initial stage. So what happens? You need to do for the allocation of epsilon at the 2 cells. That is the required one. Now let us go with the allocations part. So if everyone is clear with this, I will rewrite the table with allocations. Can I? Yeah, thank you. Just hold on a moment, I will take that. And if you go with the allocations, 0 into 10, you got 10 here as the allocation. Since there is no need to write the demand and supply again, we just discuss about the degeneracy. So 7 into 4, 4 is allocated here. 6 into 3, 3 is allocated here. And 9 into 5, it is allocated here. And then you have 8 into 3, 10 into 8, 8 is allocated here. So 1, 2, 3, 4, 5. So these are the total allocation substitution. Accepted? Now, if you want to introduce the epsilon, right, where we need to introduce in general? So in the entire cost matrix, we should go with the smallest value. So in the smallest value, you can consider that there are two zeros. You can choose epsilon at any position. So what happens? You can fix epsilon here or here so that a closed loop will not get formed. Am I correct? Right. So by arbitrary case, I will take epsilon at this position. I will allocate epsilon here. I think you accept for this thing. Yes or no? Right. Again, I can have another epsilon. I can allocate that anywhere. So apart from taking 0, I will allocate the epsilon here. Now let us check that whether a closed loop forms there or not. So if you trace a path, you should not get a closed path. Yes, we can apply other 0 also. It improves the iteration process, that's it. Because if you allocate epsilon at the two zeros, even though you didn't get a closed path there, in the next iteration what happens? You calculate ui and vj values. Since you get a positive value, you need to move epsilon from one place to the other, isn't it? So to move two epsilons, you will have to go for two iterations again. It is a waste of time. So I have chosen the next smallest value 7. So 7 is placed here and here. I can put epsilon at any place. Suppose if I put epsilon here, then what happens? I can have a closed path 6, 7, 0, 0. This closed path I will get, that should be violated. It should not get like that. So I have taken epsilon at this position. I think it is understandable to all. Okay? Right. Now let us calculate the u and vj values as usual. Since there are so many allocations here, generally we put a 0 there. So let us take u1 is equal to 0. So corresponding column values, you can take that from this. v1 is equal to 7 because this is the basic cell. v2 is equal to 6. v3 is equal to 9. And you are going to calculate the other. So v5 is equal to 0. And u3 must be equal to 0, so that 0 plus 0 will be equal to that. And you are going to take v4 is equal to 12. Because this is 10, so that I can take, this is minus 2. I can do like this, the values. So on checking, you can verify where you get a positivity if you calculate the penalties. For the non-basic cells, where there is no allocation, you can check for that where you have a positive sign, the positive penalty you can find. So u3, v3. So this thing you are mentioning, right? Because 9 plus 0 minus 8, 1, that is the positivity, right? Next thing. Can you find any other positivity there? That's all. That is the only positive we have. That's it. Now, let us do like this. Suppose it means that it has the positivity in the sense, by allocating something here, you can improve the solution. Is that right? Yeah. Now we are going to construct a closed path like this. The path must go to basic cell to basic cell. So what happens here? You pick up this thing. So the path came like this. So here you have 8. This is my into mark. Here this is 0. The allocation is 10 here. Here the allocation is epsilon. Here the allocation is 5. So you give the symbols plus, minus, plus, minus. Accepted? I am not taking the cost values, I have taken the allocation values. So among the negative signs ones, which one is the smallest thing? 5. So we need to subtract 5 from the negative signed ones, and the same thing should be added to the positive signed ones. So if you do the same thing, it will become a non-basic cell. Here you will get the allocation 5, and it will become 5, and it will become epsilon plus 5. Am I correct? Right. Since you have done only one positivity and it is, yes, where can we write just 5 in place of epsilon, right? Because epsilon is arbitrary, we simply just write 5. That is also acceptable. If you want a specific means that I have done something there, you can write 5 plus epsilon. Otherwise, epsilon is tending to arbitrary 0. So you can write it as simply 5. That is also acceptable. Since you have done the modification there, now you can go for the rest of the check. How it comes? 7 into 4, 6 into 3, that is 0 into 5 neglected. This is 7 into epsilon neglected. This is 10 into 8. Then you have 8 into 5. However, you can say that 7 into epsilon is equal to 0. Then you can say that 0 into 5 and 0 into 5. Total 1, 2, 3, 4, 5, 6, 7 allocations are there. The answer is nothing but 166. Accepted now. So that the degeneracy is removed. I think it clarifies your doubt. So did any one of you have any other doubt here? How to allocate route? That means the path. That's your doubt, right? Yeah. So if you want to go for a closed path, the fundamental concept here is the closed path must have always even number of cells. That is 1. Second, we should move either horizontally or vertically, not diagonally. These two things we usually care of. And another thing is you should move from basic cell to basic cell where there is allocation. That's it. Now what happens if there is, suppose here you have epsilon put. If you have traced a closed path like this, whether to consider this allocation or not is a doubt in your mind. So we skip that basic cell and we move to the next basic cell. Suppose let us take an issue like this. Suppose we have a path. This is one basic cell, one basic cell, one basic cell, one basic cell. This is your X mark. I am taking this type of situation. Now from X, if you want to construct a basic cell, how to move? Is that a doubt? So we should not only that, suppose the loop exists in the middle of the cost matrix, then also we can take. There is no need to choose the corner cells always. Whenever there is a basic cell, and if you can trace a path there, you can go for that. That's it. Please understand one thing, that if you trace a closed path at the end of corner cell or in the middle, the fundamental thing is by tracing a closed path around the basic cells is nothing but you are not violating the supply and demand constraints. That's all we need to show. We are not violating supply and demand constraints, because since you are taking the minimum of the negative sign cells, the total supply as well as total demand will be equal. In such a way you are doing the allocation. That's it. That may be happen in the corner or in the middle. So you are doing a modification in the middle as well as at the end. That's it. So let me say in a simple consideration. So I want to finish here. Since you have three basic cells here, we construct a path like this, going here, going here, going here, going here. We skip this basic cell. There is no need to consider that. Because always a close, because if you want to go allocation for plus minus symbols, then what happens? You should come up with plus and plus at the same time. There you got a confusion. That's why the closure path always contains even number of cells there. And coming to the other one, yes. However, just introduce one epsilon there. Again, you need to go for the optimization, calculating u and vj values. Again, you go for another epsilon introduction. Nothing wrong at all. The advantage here is, if you introduce two epsilons at a time, tracing closure path is somewhat easy. Because by introducing epsilon at the convenient way, you can have a convenient closure path, right? That's it. So in the first iteration, let us introduce only one epsilon. Then in the next iteration, introduce one more epsilon. In the final one, a cell will be modified. So you need to construct three tables. So without any confusion, that also you can do. Nothing wrong at all. Okay. Because this kind of situation happens, as per your doubt, since it is a dummy row, you have 0, 0, 0. Even though if you put epsilon there, it is not at all disturbing the supply and demand constraints. Because it gets a number there or not, that doesn't matter because you are multiplying with 0. So what happens if there is no dummy 0? It is a balanced transportation problem, and there you need to introduce two epsilons. Then you have a tie situation. I think you got my point. So what happens in such type of situations in the whole matrix? You take the smallest cost value and the next smallest cost value. At the two positions, you introduce epsilon. The purpose of epsilon is nothing but just to remove degeneracy. That's all. Even though if you calculate the solution here, you got an optimal solution in which epsilon has no effect at all. You just moved the place of epsilon. That's all. Because it won't give any effect on supply and demand values, epsilon. Okay. So any other queries, please? So for maximization, I think I have taken one more problem on this transportation maximization concept. I hope so. I have taken a problem on this also. So if you have a profit matrix, by subtracting the maximum element from it, you get into the relative loss matrix. Then you apply VAM on this, so that you will get minimum loss. So in the material, for profit matrix, they have continuity original table. Can you post that number, please, if you have anything with you? Did they multiply with the negative sign? So here we need to understand that the value which is given there is nothing but after subtracting the highest value from the original table. Can you understand like that? The case of maximization. Okay. Yeah, you can post it. So you have unbalanced transportation problem. So a departmental store wishes to purchase the following quality of ladies dresses, dress type, quantity, manufacturer, total quantity. The store estimates that profit per dress will vary with the manufacturers as shown in the matrix below. How should orders be passed? Right. So it is given that 2.75, 3.50. Yeah. So you are saying that these values are nothing but the profit values. Yes, they didn't convert it to the loss matrix. I have seen that. Yeah. The store estimates that profit per dress will vary with the manufacturers as shown in the matrix below. So here I can just say only one thing, that even though we cannot rely on the standard textbooks also at this moment, that is the only word left with me. So this type of situation is occurred for you in how many problems? Can you say? Only 2 or 3? Have you gone through the total material? Right? So did you find any kind of discrepancy? The printing mistakes alone are there except this question. So you please give the comments on where you got the mistakes, so that I will rectify them. Because after having this lot of material, even though we have scrutinized, we got something. So did you find anything with regard to the linear programming where simplex method, graphical method, etc.? Many are there in simplex method, right? Fine. You just give those numbers, I am going to rectify that. I give the modification for them. Thank you. Fine. So the two things what I want to cover for today's session are completed. And one thing I have already mentioned, that if you want to go for the maximization of the problem, apart from converting the profit into loss, we can say that all values are multiplied with -1 and we perform VAM, that method is also acceptable, and you do the regular procedure and find the solution as it is. That is also accepted. But majority of the others has taken the method that as and when a profit matrix is there, convert into a loss matrix and solve the problem. And one more question, we'll have a doubt that if nothing is mentioned, you got some negative values there. And he didn't mention that it is a profit matrix. How to proceed then? So if you understand from the problem itself that it is a profit matrix, convert the maximization problem into minimization by subtracting the highest element, do the procedure. Just like this, profit matrix into loss matrix. Another one is, you just ignore these two values. You just ignore these two values, and for the rest of the values, you do the as usual procedure. If you didn't mention that it is a profit matrix, that we do. I think that kind of problem once it is given. So we ignore these values, and for the rest of the values, you do the regular procedure. Yes, alone cost values, then we neglect them. Because negative cost indicates the profit there, right? So the whole idea of northwest corner least cost or VAM is nothing but you are selecting in each row the smallest cost. Why you are selecting a smallest cost? Because if you do some allocation, the transportation will be minimum. If it is negative means, there is a need to select that one. That was the thing. So we neglect those values, and for the rest we perform the value as it is. So if you multiply with -1, means you have converted cost matrix into profit matrix. Because she already indicated that it is a cost matrix. So I just want to find a relative material for it. Because I have solved a similar problem where I have neglected the thing, I have obtained the solution. By neglecting the two things, I have performed VAM and the solution is obtained. So I can say for the whole UPSC thing, you can just find one or two problems in the whole with regard to transportation problem having negative values in the cost matrix. That's why we neglect the negative signed ones, and for the rest of the things we perform VAM as it is. So you just say that in a cost matrix, I have given blanks for you. Then tell me what you do. How can you take 0? You cannot take 0. Because cost values are always usually positive. They can't be 0. Of course, you are introducing a dummy thing to make it 0. But generally cost is always positive, right? So just imagine a situation that I have given like this. A 3x3 matrix. Now what is our opinion on having X there in solving the problem? Because the value of X is unknown. Yeah, I will give the answer for that question by neglecting the two things. Right. So we neglect X here. For the rest of the things, you are performing the same procedure. So X indicates what there? It must be a huge value. The cost is unknown. Sometimes it will be more, sometimes very less, sometimes it is undefined, sometimes it is a profit one also, it is undefined. So I feel that whenever you have one or two values given with negative signs, you consider them as x, so that we skip the part and we do the rest of the things. So in such consideration, I have taken the decision. Okay. So tell me, is it a balanced one? So 11, 19, 19 plus 8, 27 plus 13, 40. And here we have 40. It is a balanced transportation problem, right? Right. So let us calculate the penalties. Here the penalty is nothing but 3. Here I will neglect this thing, the penalty will be 1. Here I will neglect this thing, the penalty is 3. And here the penalty is 2 here. Here the penalty is 5. Here the penalty is 4. Here the penalty is 3. And here the penalty is 1. I have done like this, neglecting the negative values. For the rest of things, I am doing with the as usual procedure. Now, which one we need to choose? The highest penalty with 5, right? So the smallest element is nothing but 2. You are not going with -1. You are neglecting this. I am treating this as an x. So taking care of the supply and demand constraints, 2 into 3 will come here. So this gets cancelled and it will become 6. So again, I am calculating the penalties as usual. Is this accepted to all? Neglecting the 2 negative values, doing these things. So if we calculate the penalties again, here you have the penalty 3. Here the penalty is 2. Here the penalty is 3. Here you have 2. This gets cancelled. The penalty is 4 here. The penalty is 3. The penalty is 1. Again, the highest penalty goes to 4. So here we take 0. So 0 into 8 will take. It will become 6. Is this acceptable? Say. Any questions for anyone? Okay. So here the penalty will be 1. Here the penalty is 2. Here the penalty is 3. Again penalty 2, penalty 3, penalty 1. Now tell me which one you want to choose. 3 occurred for twice, column or row? Row. So if you go for the smallest is 0. Take for supply and demand 0 into 13. It gets cancelled, it will become 4. Again the penalty will be 2, the penalty is 7, the penalty will be 2. And here again penalty is 2 and penalty is 1. Obviously you should go with 7. The smallest one is 1. So 1 into 6 will come here. It will become 2. This gets cancelled. Again the penalty is 2 here. The penalty is 2 and 2 here and 1. So which one you want to choose? You can choose column also. I am taking the inputs taken by you, that's all. Because if you take this one, in the next moment that is going to be cancelled. You can choose row or column as it is. Right. So if you take this column, for instance, because 2 you have there, the smallest element is 3. Taking care of supply and demand, it will be 2. It gets cancelled, it will become 2. So coming here, the penalty is 6 here, the penalty is 5, the penalty is 1. Obviously, we should go with 6. 6 into taking care of this 6, it will become 2. It gets cancelled, and for 5 you have 2. That was the allocation. You can sum up that. 6, 12, 18, 36, 18 plus 10, 28 plus 36, 54. 64. Yeah. 64. That was the case. I have searched for some other books. So what are the standard book you take usually? They didn't give any value with negative symbols in the cost. So I have treated that in a transportation problem, if x is given to you, the value is unknown. So that you simply skip x, for the rest of the things you do the problem. The same thing is applied here. And further reference, you can go for the optimality check also for having u and vz values calculating. That also you can do. If it is asking for optimal solution. If it is just initial feasible solution, it is enough. 64 is the basic feasible solution. Because 1, 2, 3, 4, 5, 6, 7 allocations are there. You can check the values. 5 plus 3, 8. 7 allocations are correct. If all are negative, it is nothing but a profit matrix. Convert it. Just see one thing. If all values are negative, you feel that it is a maximization problem. So what happens? We do the same thing as usual, and at the end the values will be taken. And one happens, if it is given profit matrix, we convert it into loss matrix. I can say only one thing. If all values are negative, you are going for the maximization. That's all. The procedure is as usual. There is no change at all. The procedure is as usual if all values are negative. Yes, because one of our friends already asked that if you want to do maximization, what are the methods available? I mentioned that for maximization, you subtract all the elements from the highest element, you will get the loss matrix, do the problem. Another one is multiply all elements with minus so that you perform the same method. No difference at all. If only 1 or 2 values are there, there is a different issue. If all values are negative, you do the same procedure. So can I give the implication of dual simplex in a short manner? Yeah. I think I have taken a doubt on dual simplex. I hope so. Maybe not for you, for the others. So since we have 5 minutes left, I simply say like this. In simplex method, you will have the basic variables, and first we select the column, then we select the ratio, and you have the pivot element. Am I correct? All of you. Right. Dual simplex is opposite. Writing dual means you are converting the problem into another objective function and doing the thing, and you have a transposed matrix and you are doing the problem. Let me say, for simple instance, now what happens whenever greater than or equal to or less than or equal to things are there, always we introduce slack variables, surplus variables, artificial variables, isn't it? So to avoid that confusion, the bigger method confusion, dual simplex is introduced. Actually, as and when you perform S1, S2, A1 values, here in the basic solutions, you will have their values are positive. Yes or no? Always the values are positive. And we write the inequalities in a such a way that always right hand side must be positive. You should not get negative sign on the right hand side. GL simplest method says that you take the objective function, always GL simplest will be applied for the minimization problem in general. You convert the maximization into multiplying the objective function with -1. So it will become maximum z as minus 2x1 minus 5x2. Then what happens? For maximization, all the inequalities must be less than or equal to type. Since this is greater than or equal to, you multiply with -1, it will become minus x2 minus x1 is less than or equal to -3. Since you have two inequalities, you have two slack variables here, s1 and s2. So for s1, the solution will be 1 here, and for s2, the solution will be -3 here. So as and when you apply GL simplex method, in the solution part, always you have the positive values. But in the solution part, you will have negative values also there. And while performing the iterations, suppose let me say, I have the solution values like this, 1, -3, -6. Now what happens? I go with the highest negative one. So first I select the row. And to select the pivot element, I have the row values. After calculating Zj and Cj minus Zj, I will divide Cj minus Zj values with row values. So you will get the ratio. I will take the value where you have the minimum ratio, that is the pivot element. That's it. The same procedure we follow. Row operations performation, doing calculation, optimality check, everything is as usual. The only thing is, first we select the row. In the negative values, take the highest negative signed one. Calculate Cj minus Zj. Cj minus Zj values are divided by row values. You take the smallest ratio, that is the pivot element. The rest of the thing is as usual. That's it. In a short nutshell, that is GL simplest method. If you want a problem, I will post a problem for you in reference for Telegram. Maybe today or tomorrow. That will clarify your doubt.